There is something sitting on your bed right now that you have probably never thought twice about. You sleep on it every single night. You press your face into it for hours. And if you pulled back the pillowcase right now and actually looked at what was underneath, there is a good chance you would never want to touch it again. Because pillows turn yellow, not a little yellow, not barely noticeable yellow. We are talking deep, stained, aged, brownish yellow. The kind of color that makes you feel like you have failed some basic test of being a human adult. Most people just buy new ones, toss the old ones in a bin bag, and pretend it never happened. The pillow industry counts on exactly that. But here is what almost nobody in the Western world knows. In Japan, for over 100 years, there has been a powder. A simple, cheap, almost laughably basic powder that costs less than $2. And when you apply it correctly, something happens to those old, yellow, almost unrecognizable pillows that honestly does not seem real until you see it with your own eyes. The yellow does not just fade, it disappears completely, like it was never there. And the strangest part? This powder was never invented for pillows. It was never invented for cleaning at all. The story of how it ended up transforming yellowed fabric is one of the most unexpected journeys in the history of household chemistry. And once you understand what it actually does inside the fibers of your pillow, you will never look at yellow stains the same way again. Stay with this, because what comes next changes everything. It starts with a woman in Osaka in 2019. Her name does not matter. What matters is what she posted online one Tuesday evening after spending less than 5 minutes in her kitchen. She had taken a pillow so yellow it looked almost orange. A pillow she had owned for 4 years. A pillow she had already decided to throw away. And she placed it in a tub of warm water mixed with something she had found in her grandmother's cabinet. A small paper packet, faded label, sold at every 100 yen store across Japan. She let it soak, and then she posted the before and after. The internet in Japan lost its mind. Within 48 hours, that single post had been shared over 200,000 times. People were calling it impossible. They were calling it edited. They were accusing her of using 2 completely different pillows for the photograph, but then other people tried it, and then more people. And the results kept coming in, post after post after post, pillow after pillow after pillow, all of them showing the same jaw-dropping transformation. Bright white on the right, deep, embarrassing yellow on the left. And always, always the same tiny powder packet sitting in the frame like it was the most ordinary thing in the world. But here is the question that nobody was asking loudly enough. Why did it work so well? Why had no one in the West ever heard of this? And what exactly was in that little packet? To understand the answer, you have to understand the problem first. Because most people have completely the wrong idea about why pillows turn yellow. There is a very common assumption that yellow staining is about dirt, that it is about dust mites, or unwashed hair, or general uncleanliness. And while those things can contribute over time, they are not the real culprit behind that deep, set-in, impossible-to-wash yellow that every pillow eventually develops. The real enemy is something you cannot see, cannot smell, cannot control: your own body. Every single night while you sleep, your body is doing what human bodies have always done. It sweats, even when you feel perfectly cool, even when the room is cold, even when you have no memory of sweating. Your body is releasing moisture, microscopic droplets that pass straight through your pillowcase and soak directly into the pillow beneath. And sweat is not water. Sweat contains urea, salts, fatty acids, and most importantly, compounds called apocrine secretions, molecules produced by glands near the neck that are designed by your body to break down and oxidize when exposed to air. When those compounds soak into the dense fibers of a pillow and then oxidize night after night, month after month, year after year, they bond to the fabric at a molecular level. They create chromophores, that is the scientific term for molecules, that absorb specific wavelengths of light and reflect others. In this case, they reflect yellow. This is not a surface stain. This is a chemical change happening inside the actual structure of the fiber. And that is precisely why normal washing machines and normal detergent cannot fix it. You can run a yellowed pillow through a hot wash 10 times, and it will come out exactly as yellow as it went in, because detergent is designed to lift and remove surface particles. It was never built to break apart chromophores that have chemically bonded to fabric at the molecular level. That requires something completely different. That requires oxidation, and this is where our Japanese powder enters the story. But to really understand why it works, you have to go back, much further back than 2019, back to the 1700s, before washing machines, before detergent, before synthetic fibers, back to a world where keeping white fabric white was one of the most laborious, expensive, and socially important tasks a household could undertake. In Europe, during the 18th century, white linen was a statement. Your collar, your cuffs, your bedsheets, the whiteness of your fabric declared your status. A yellowed shirt was not just a cosmetic problem, it was a public humiliation. The hunt for something reliable led European chemists in the late 1700s to chlorine bleach. Discovered and refined by chemists in France and Sweden, chlorine bleach spread across Europe rapidly. It was fast, it was powerful. And it was, in ways that took another century to fully understand, also quite damaging to delicate fabrics. Chlorine bleach works by breaking molecular bonds indiscriminately. It attacks chromophores, yes, but it also attacks the cellulose structure of cotton fibers themselves. Use it too often and fabric becomes brittle, thin, weakened. In Japan, the approach was entirely different. Japanese textile tradition places enormous value on the longevity and quality of fabric. The concept of motainai, which means something close to the deep regret of wastefulness, shaped how Japanese households thought about their belongings. You did not discard, you repaired, you maintained. And so while European chemistry was rushing toward the power of chlorine, Japanese household tradition was quietly perfecting something gentler, something that worked not by breaking everything apart violently, but by targeting the specific chemistry of yellowing with surgical precision. That something came originally from wood ash. When you burn certain types of wood and collect the ash, that ash is extraordinarily alkaline. Mixed with water, it creates a solution that Japanese households had been using to treat fabrics for at least 400 years. They called the practice akunuki. Literally translated, it means the removal of harshness. And what it was removing, though nobody understood the chemistry at the time, was precisely the class of molecules responsible for yellow staining. Wood ash water is rich in potassium carbonate. Potassium carbonate is alkaline. When you expose fatty acid compounds to a strongly alkaline solution, a chemical process called saponification occurs. The fatty acids are converted into soap. They become water-soluble. They release their bond with the fabric fiber. They lift away. And simultaneously, in that same alkaline solution, a secondary oxidation reaction takes place that attacks chromophores directly. The yellow molecules are chemically altered. Their ability to reflect yellow light is destroyed. They become colorless. This was not magic. This was not folk wisdom based on superstition. This was, 4 centuries before modern chemistry could explain it, a perfect empirical understanding of the exact process needed to reverse yellowing. The Japanese households practicing akunuki did not know about chromophores. They did not know about saponification. They just knew it worked, and they passed that knowledge down. Generation to generation, grandmother to granddaughter. The specific powder that the woman in Osaka used in 2019 is called oxygen bleach in Western terminology. In Japan, it is sold in small packets at 100 yen stores containing the core active ingredient. Sodium percarbonate, this is the powder, $2. A faded packet at a discount store, sodium percarbonate. And when you understand what it is and how it behaves, the results it produces stop seeming miraculous and start seeming completely inevitable. Sodium percarbonate is made by combining 2 things you already know, washing soda and hydrogen peroxide. In dry form, these 2 compounds exist in a stable crystalline structure, completely inert, sitting quietly in that little packet. But the moment they hit warm water, the structure dissolves, and what releases is a simultaneous flood of 2 of the most effective yellowing reversal agents in existence. First, the sodium carbonate provides powerful alkalinity. It attacks the fatty acid deposits left by sweat. It converts them through saponification. It breaks their molecular grip on the fabric fibers. Second, and this is the part that makes oxygen bleach fundamentally different from everything else you have ever used, the released hydrogen peroxide does something elegant. It decomposes into water and nascent oxygen. This is not regular oxygen. These are oxygen atoms released at the exact moment of chemical decomposition, before they have had the chance to combine into stable molecules. Nascent oxygen is extraordinarily reactive. It seeks out and bonds with chromophore molecules, the exact compounds causing the yellow color. When it bonds with them, it alters their electron structure. Their ability to absorb and reflect specific wavelengths of light is destroyed. They become optically colorless. They do not wash out of the fabric. They are not removed. They are chemically transformed right there in the fiber into molecules that no longer produce a visible color. The yellow does not go away. The yellow is annihilated at the molecular level. And because this entire process is selective, targeting specific types of molecules while leaving the cotton structure completely intact, there is no fiber damage. Your pillow does not just look cleaner after this process. It genuinely is cleaner at a level your washing machine has never achieved and physically cannot achieve. Now, here is where the story gets uncomfortable. Because there is a natural question sitting in the back of your mind right now. If this works so well, if it is so cheap, if the chemistry is so clean and so effective, why does nobody in the Western world use it? The answer is not complicated. It is just a little bit ugly. Sodium percarbonate has been commercially available in the West for decades. It is not a secret. It is an ingredient in some premium laundry products. But it has never received the marketing attention or consumer awareness of chlorine bleach. And there is a reason for that. Chlorine bleach is cheap to produce, has enormous industrial infrastructure behind it, and is a repeat purchase product precisely because it damages fabric over time. You bleach your sheets, they yellow again. You bleach them again, they thin and weaken. After a year or two, you buy new sheets. The cycle repeats. Sodium percarbonate does not damage fabric. If you use oxygen bleach correctly on your pillows every few months, those pillows will last significantly longer. They will not yellow severely. They will stay close to original condition for years longer than you expected. And a customer whose pillows last longer is a customer who buys fewer pillows. This does not serve the interests of companies whose revenue depends on you needing to replace things. That is not a conspiracy. That is just the mathematics of consumer economics. But the Japanese market relationship with household products is different in important ways. The cultural emphasis on longevity means that products which genuinely extend the life of belongings are actively valued and marketed. Sodium percarbonate products sell strongly in Japan, not despite their effectiveness, but because of it. Which is why an ordinary Tuesday Evening Post in Osaka could cause 200,000 shares overnight. Because for Japanese households, this was not a revelation. It was a reminder, a piece of knowledge that had always been there, passed down from grandmothers, sitting on a shelf in the 100 yen store where it had always been. The reaction was not shock, it was recognition. But when that post crossed language barriers and reached Western audiences, the reaction was completely different. Because for Western audiences, this was genuinely new information. And new information about something as universal and as embarrassing as a yellowed pillow travels fast. Within a month, YouTube channels in English, German, French, and Spanish were testing the method. The results were consistent, not universally perfect. Synthetic fibers respond slightly differently than natural cotton. Very old pillows with decades of staining show significant improvement, but not always complete transformation. Temperature matters. The powder works best in water between 40 and 60 degrees Celsius. Too cold and the sodium percarbonate does not dissolve completely. Too hot and the hydrogen peroxide decomposes too rapidly before it can do its work. Concentration matters. The standard recommendation is approximately 100 grams of sodium percarbonate per 10 liters of water. Soak time matters. The optimal window appears to be between 1 and 6 hours. Under an hour, and the reactions are incomplete. Over 6 hours and redeposition can begin, where loosened compounds settle back onto the fabric. But when you get those variables right, the results are consistent. Almost without exception, across pillow types, across staining levels, the process produces a transformation that challenges what you thought was possible with cheap household chemistry. People who tested it did not just report that their pillows were slightly whiter. They reported that they looked new. They reported holding them up to the light and not being able to identify the staining that had been visible before. And then the questions started getting more interesting. If it works this well on pillows, what else? White shirts with armpit yellowing, old towels, grout between bathroom tiles, canvas shoes. The applications kept expanding, and in almost every case, the compound delivered. The fundamental chemistry is the same in every application. Chromophore destruction, fatty acid saponification, molecular level cleaning that leaves the underlying material intact, and the staining chemically neutralized. There is a woman in Kyoto who is 91 years old. Her granddaughter, who works in textile conservation, tells a story about visiting her as a child and watching her grandmother soak household linens in a large ceramic tub. The powder she used came from a blue paper packet that the grandmother had been buying from the same neighborhood store for over 40 years. She never called it oxygen bleach, she called it the freshening powder. And she used it 4 times a year, at the change of every season. The household linens in that home, some of them more than 60 years old, were white, not yellowed, not worn thin from chlorine treatment, white, still in use. Still functional, still beautiful. This is the thing that gets lost in the Western narrative around cleaning products. The best cleaning is not the most aggressive. The best cleaning is the most precise. And for a century, through folk knowledge, through habit, through the practical wisdom of generations who could not afford to replace things when they wore out, Japanese households had been practicing precision cleaning. The rediscovery of this practice in the age of social media carries an irony that is hard to miss. We live in an era of unprecedented access to information. Every scientific paper ever published, available at a search. Every traditional practice from every culture on Earth, potentially viral at any moment. And yet somehow, the knowledge that a $2 powder could restore yellowed pillows was not common knowledge in the Western world. It took a woman in Osaka, a Tuesday evening, and a photograph to cross the information gap that decades of consumer chemistry education had not crossed. This says something about how knowledge actually travels. It does not always move through official channels. Sometimes it moves through a photograph, a before and after. The undeniable visual evidence that something extraordinary is possible with something absolutely ordinary. The pillow that sparked 200,000 shares was not extraordinary. It was an average pillow, yellowish, embarrassing, the kind you own and try not to think about. And after an hour in a tub of warm water and a $2 packet of powder, it was white. The kind of white that makes you feel like your home is clean. The kind of white that makes you feel, without being able to entirely explain why, like things are in order. There is a deeper truth embedded in all of this. Underneath the chemistry, underneath the cultural comparison, underneath the viral post and the before and after photographs, the truth is about what we believe is possible. Most people look at a deeply yellowed pillow and feel resignation. They assume some things cannot be fixed. They assume age and use leave marks that cannot be undone. They assume the answer is always replacement, always spending more, always beginning again, rather than restoring what already exists. And here's a powder that challenges every single one of those assumptions. Here is proof, physical and visible and reproducible by anyone with a bathtub and $2, that the resignation was never necessary, that the yellowing was never permanent, that the chemistry of renewal was always available, sitting on a shelf, waiting, inexpensive, patient, ready to do in one afternoon what years of ordinary washing had failed to do. The pillows in your home, the ones you have been meaning to replace, the ones hidden under cases you never remove because you do not want to confront what is underneath, they are not ruined. They are just waiting for the right chemistry. And now you know what that chemistry is. Now you know where it comes from. Now you know why it works. Now you know why a grandmother in Kyoto trusted it for 40 years, and why a post in Osaka could stop 200,000 people mid-scroll and make them think, for just a moment, that something they had accepted as inevitable might not have to be inevitable at all. Some things in this world are complicated. Some problems require expensive solutions and years of research. And some problems, the everyday embarrassing ones, the ones we quietly live with because we assume they are unfixable, some of those problems have a $2 answer that has been hiding in plain sight for 100 years. You just had to know where to look.